Hi everyone, we are from Group 4. My name is Iman Ehsan Bin Hassan with my team member Mek Zhi Qing and Zereen Huey. Our topic for this project is prediction of diabetes based on the study factors using recursive feature elimination. So for introduction, diabetes is a chronic condition brought on either insufficient insulin production by the pancreas or inefficient insulin used by the body. Insulin is a hormone that controls blood sugar levels. Uncontrolled diabetes frequently causes hyperglycemia, known as a high blood glucose. Some of the symptoms of diabetes are normal thirst, frequent urination, weight loss without exerting effort. There are two types of diabetes, which are type 1 diabetes and type 2 diabetes. The body is unable to produce insulin if you have type 1 diabetes, and insulin need to be taken every day, while our body use insulin body poorly if you have type 2 diabetes. So in this project, we will propose a model to predict the factor that will lead to diabetes using the recursive feature elimination method. So for some problem background, according to research, a total of 536 million people from the age of 20 to 79 years old are diagnosed diabetes in 2021. The diabetes might be hard to be aware of by the patient at the early stage if no symptoms appear. The rising prevalence of diabetes is associated with the aging of population. The patient will receive medical care after doing specific tests that can confirm whether they have diagnosed diabetes. So, the process of selecting the feature is complicated to ensure that a high accuracy result can be obtained to produce a quality predictive model. The prediction model created by using recursive feature elimination has a lower accuracy and it should be increased. So, these are some of our problem statements which, based on the studied factors, is challenging to achieve high accuracy, and the accuracy of the diabetes prediction model created using recursive feature elimination has a lower accuracy. Some of the objectives of our project are to investigate and analyze the recursive feature elimination in the diabetes prediction, to develop the diabetes prediction model which can improve the accuracy using recursive elimination method, and last but not least, to evaluate the effectiveness of the diabetes prediction model in terms of accuracy and reliability using recursive feature elimination. So, our scope of the project the recursive elimination method is applied in diabetes prediction. The data set used in this research is obtained from UCI machine learning consisting of PIMA Indian Diabetes Database. So, the dataset is obtained from Kaggle, namely PIMA Indian Diabetes Database. It consists of 8 medical predictor variables, which are pregnancy, glucose, blood pressure, skin thickness, insulin, body mass index (BMI), diabetes pedigree function, and age. So for indicator variable, the outcome are either 0 or 1. So first of all, we need to import the dataset in our coding. Some of our library are imported first, such as NumPy, Pandas, Matplotlib, Seaborn, and Warnings. After that, the dataset is imported, which is diabetes.csv. So it consists of 768 rows and 9 columns. So we use data.describe to have a statistical summary of dataset.
I'm Mek Zhi Qing, and I will continue to explain from the part data wrangling. So in this part, we will use the function data.isNow.sum to check for the existence of missing value in our dataset. So based on the result, we can see that all of the value print out is 0, so there is no missing value in our dataset. Then we continue to check for the total number of 0 values exist for the variable. So based on the result, we can see that the number of 0 values in glucose is 5, blood pressure is 35, skin thickness is 227, insulin is 374, and finally BMI is 11. So actually in these cases, the 0 value should not be exist. So the 0 value is actually a missing value. So we will continue by replacing the number of 0 values in those variables with their mean. After replace, we will check again whether the 0 value is still available, and based on the results, we can see that there is no more 0 values available. Lastly, before proceeding to data analysis, we will export our modified dataset to a new CSV file, namely Modified Diabetes Dataset. Next, software and hardware requirements. For software, we use Visual Studio Code and download the Python extension. Some of the Python packages that we use are NumPy, Pandas, and Matplotlib. For hardware, we actually do not have any specification on it, but we use an Intel-based computer with Core i5 processor and random access memory with 16 GB. So this is a flowchart of proposed approach where we will start by getting the raw dataset from Kaggle. Then we pre-process the data by checking the null values and removing the zero values, followed by trend test split. Then we will get the important features that is related to diabetes by using the recursive feature elimination. After getting the important feature, we will build the model using the random forest classifications. Then we will perform prediction on it. And finally, we will perform a model evaluation to see how is the performance of our predicted model. Next is the exploratory data analysis. So we actually carry out the correlation analysis to determine whether there is a relation between the feature variables and target variables. So we actually print out the values of the result and also plot a heat map on the results. Here is the results of the correlation analysis where the glucose variable it gets the highest dependency compared to other variables followed by the BMI, age, pregnancies, and insulin. So in between the variables, we can conclude that there is actually a high correlation between the target variable and feature variables. Hence, this feature can actually be selected to predict the outcome. Then we will start for model development. The first step of model development is to split the data into input and output, which is X and Y. The X will consist of all the feature variables, which is the input, and Y will consist of the output variable, which is the outcome. Then the trend test split is carried out to separate the data into training data and testing data. The test set is set as 0.2, where 80% out of the total data will be categorized as training data, while the remaining 20% will be the testing data. The random stat is set as 7 to ensure that the splitting of data in trend and test is deterministic for every execution. So the data size for the training set will be 614 rows and 8 columns, which is 80% from the total data. And for the testing set, it will be 154 rows and 8 columns, which is 20% from the total of the data. Then we will start to build the model, where we actually build a random forest classifier model, and we also use the recursive feature elimination to rank all of the egg features. So for the step previously, we actually rank the features, but we do not select it for building the model. So for now, we are selecting 6 features out of the F features to build the model. So we print out the features, we can see that is glucose, blood pressure, insulin, BMI, diabetes per degree function, and also age, which is the same as the 6 top ranking that we list out just now. Then we will make prediction on it.
I'm Zereen and I will continue to explain about the model evaluation. First, we will calculate the accuracy score for our model. The result shows that accuracy score for training model is 100%, while the accuracy score for testing model is 81.17%. Next, we also calculate the confusion matrix. The result shows that 84% which do not diagnose diabetes is rated correctly as normal, 13% which do not diagnose diabetes is rated wrongly as diabetes patient, 16% which diagnose diabetes is rated wrongly as normal, and 41% which diagnose diabetes is rated correctly as diabetes patient. For our predictive model, the result for sensitivity or recall is 0.72, while the result for specificity is 0.87. Both of them considered as good since nearly to 1. The F1 score is 0.74, which also considered as good since its value is near to 1. The area under the curve, which is AUC score, for our model is 0.87, which is high means that can detect more correct result compared to wrong result. Our receiver operating characteristics curve, which is ROC curve, is located on the top left corner and it indicates good performance level. As a conclusion, we successfully increased the accuracy and performance of diabetes predictive model using recursive feature elimination methods. And from the beginning of 8 diabetes features, we found that 6 features are most related to the diabetes for the prediction process. That's all from our group and thank you for watching our video.